So I'm Brian Cox with Phison. We are headquartered in Taiwan with U.S. headquarters here in Silicon Valley in San Jose. And we're going to be talking about an application of our flash memory technology that actually unleashes the economics and the scalability for AI processing, particularly in LLM training as well as inference. So a little bit of background further on Phison. We've actually been around a long time, 24 years. Over 4,000 employees. Most of those are engineers in Taiwan. In fact, we helped pioneer the first USB thumb drives and other flash memory technology, and are a key supplier of many of the key components that go into a lot of the SSDs in the industry. In fact, we are the largest supplier of the controllers, as an example, that go into all the SSDs that you're using both in your personal computers as well as in data center equipment. So we do this in a variety of different applications, and we have a large customer base, which I'll give a little glimpse of here. You'll see Phison technology in many of the systems that you see on the left, name brands that you recognize, and it's growing each day as we get more and more design wins. But we also have technology exchanges with a number of the other players in storage that you see in the center. We're buying NAND flash from them, they're buying controllers from us and firmware and such. So we're very deeply ingrained with the whole ecosystem in regards to flash memory. Given that we have control of the firmware, control of the controllers themselves that manage the reads and writes and the endurance and the security of the drives, we're able to design for very specific use cases as well. So for automotive, we supply flash memory and storage for that. For other industrial uses, we also supply the storage that NASA uses. So the lunar lander, the mission to Mars, that's Phison technology. So we were looking at other ways that we could help across industry with our knowledge of flash, and we realized there's a big challenge that we have within the adoption of AI, and that is in regards to the capacity of the memory to handle these ever-growing large models. And we can apply flash as an alternative to simply being constrained by the memory that's on the GPU card. We can now unleash tenfold more capacity at very affordable prices. Go ahead and give a little bit of the history of how we got into this. Phison, as a company, wanted to adopt AI. Our engineers said it would save us a lot of labor time. It would give us, better insights about our processes, and we're loading all our documents in there. But what we found, and this is private, this is our designs. We didn't want to put these out on the public AI platforms. We needed to have that in-house. But to do that meant that we had to buy our own infrastructure to house this. And so when the engineers said, well, if we're going to do this in-house, here's the equipment that we need. And the price tag came up to well over $1 million. And our CEO goes, that wasn't in the budget. Can you guys go back and figure out a more cost-effective way for us to apply AI within Phison? And serendipitously, which happens a lot of times here in Silicon Valley, your knowledge meets the opportunity. Given that we are in the memory industry, and that was the key driver in regards to the cost of these systems, we figured that instead of applying or loading the model solely into the VRAM, the high-speed memory that's on the GPU cards, and having to have many of these cards to get a big enough memory pool, we could instead load that onto flash, which has very high capacity and is very affordable. So with some smart engineering in the middleware, handled all the memory management, so we could then provide slices of that model to the GPU as it's needed for processing, but being able to load larger and larger models because of the flash capacity. So it completely has changed the economics of GPU processing. Now you can load the largest models and scale that easily as the industry continues to move forward and be able to do that and afford it with flash. So now it's no longer just the domain of Fortune 500 companies, but small, medium businesses, state and local government, universities can now afford to have their own AI infrastructure to run their own models, to apply their research, and it now democratizes AI for all of society. So you can see there's a number of different applications that people are looking at across industry. This is just one glimpse. You know, we were looking at it for product creation, also manufacturing, but everything from financials with market evaluation, sales prediction, all types of different use cases that many of you have heard of. We now want to make that so businesses of all sizes can afford that. But one of the things that we've run into, there's a few constraints. We talked about just the size of the models, and we'll come back to that. But also we found that there is not many people that understand how to train these models, these large language models or LLMs. That is rapidly evolving. People, you know, don't have a good comprehensive introduction to how to do this and then how to build their own models. So one of the ways that we have determined is that if we can provide infrastructure that's affordable to universities, they can give their own platform access to all of the different students. So unless you're a very large university where you have, you know, endless budget and you can have enough infrastructure that every student can get access to the systems that, you know, have the LLMs, unless you're one of the very largest universities, you're going to actually have to have all of your professors, all of your researchers, all of your students share time on that. And it may be days, weeks before you get your slot on that server to be able to do the training. If we can bring the cost down for the large language model training and research, and so you could have it on your desktop, you could have it in the form of a laptop, you could then train models everywhere, in the classroom, in your dorm room, in an office, anywhere you would like. So now everybody has access anytime they need it in order to learn how to do AI processing. So we saw that this was a big constraint. We need to enable the universities to be able to provide the students the access. And this gives a picture here in this chart of the growth of RAM that's used to house those models. And that's growing about, it doubles about every 2 years. But the rate of growth of the size of the AI models, the large language models, is going up over 400 times every 2 years. I mean, we were talking about large models just a couple of years ago of 70 billion parameters. Then it went to 405 billion parameters. DeepSeek, a few months ago, 671 billion parameters. And now Meta's talking about a 2 trillion size model they call Behemoth. So, and that's anticipated roughly in about a year. We need to have infrastructure that scales to those large sizes and also be able to afford it. So the technical challenges that we see, we talked about the knowledge base. We need to enable universities to be able to train the next generation of AI engineers, but also there's some technical challenges. We talked about in fine-tuning the rapid growth of the size of the models. There's just not enough memory. It's difficult to scale. It's expensive to scale. And then on inference, which is where you actually get, for the everyday user, you get the value out of it. When you go to ChatGPT and you enter your prompt, right? You're getting information back. And then you say, oh, I want to learn more about this, or put it in this format. And you do all these subsequent prompts. We want to make sure that that's a good experience. And what we found is that with limited memory, when you start doing those prompts and you do successive prompts off your initial query, you run out of memory. Bad user experience. So what we found is by providing the added capacity with Flash, we now enrich that experience because we don't run out of memory. So we're giving value to the greater population of people who are using these models inside a company. This is really meant for on-premise. but also for the people who are building the models with the fine tuning. The added memory solves both challenges. So I'm going to give a little bit of a product overview. We do have some of the devices that you see up there on the screen right here in front of us. So these come in different form factors to fit everything from IoT devices to laptops to workstations to servers. And behind the delegates, we actually have a display table with a number of these products provided by our partners. So we can fit this flash memory for AI purposes in really every form factor. So a little bit about the technology, and my colleague Sebastian will be coming up in just a couple of minutes, and he'll go a deeper dive into this. But basically what we're doing, as I explained earlier, is that you have the high-speed memory, goes under a couple of different names, HBM, GDDR, generally called VRAM. That's on the GPU card. And in fact, if you look at the GPU card, in many cases, the most expensive component on the GPU card is not the GPU. It's the memory. And I was just at NVIDIA's GTC trade show, and I had customers come up to me and say, you know, I was needing to load large language models, you know, on premise where I work, and I had to buy multiple GPU cards. And he goes, I didn't need the GPUs, I just needed the extra memory for a big enough memory pool. And I said, well, that's a pretty inefficient way to do it. And he said, yes. He goes, I wish I would have known about your technology earlier. Because he could then buy the number of GPUs he needed and then get the flash to give him the memory capacity. So what we do is that instead of having the whole memory pool over on solely on the GPU, is that we bring in flash as a cache, load the models there, and then take slices of that to feed the GPU as it's needed for processing. And we can do this now at 1/10 the cost of a traditional deployment that you see on the left. And this gives an example of the footprint savings. So if I'm using fewer GPU cards, which are represented by the rectangles there on the left and a little bit on the right, we shrink the number of GPU cards that you actually need, because now we can load the models onto flash. And this saves you upfront, obviously, capital cost purchase. You need fewer systems, fewer GPU cards, and it also saves on some operational costs. So fewer systems, there's lower maintenance costs, lower support contracts, less footprint. You save on that as well.
So Brian?
Yes.
Return group. That interesting about the GPU. And okay, so your premise here, or the statement here, is that I'm buying GPUs because I need the memory.
Mm-hmm.
In what cases is that not true? Is that, I mean,
and we have
maybe somebody around the table knows this because they're smarter than me on the performance stuff. But what I'm looking at is say, okay, so we constantly talk about how we need to feed the GPUs and keep the GPUs busy.
Mm-hmm.
For all that reason, so I'm like trying to say, okay, so am I not framing my
You're doing fine.
I'm stumbling all over myself right now. I would think, is it a corner case that we're having to do that this is having to happen, or what?
This is happening, well, where we're running out of memory footprint to be able to handle the growing size models is happening more and more and more, and the economics of it are happening every day.
And I understand the memory pool. I mean, we're trying to bring this memory pool, but how often is it, or how significant is it that people are buying GPUs because they don't have enough memory? That seems like that ass backwards.
That it does, and it's happening very often. That's the challenge, and that's the opportunity that Phison saw, that we could help alleviate that problem. Now, if you have a small model and it fits within the GPU memory, that's fine. But you'll see some charts, you know, in a few minutes that show that where you fit it within the memory pool that's on the GPU card, you're fine. But then as you grow that model, you then run out of the memory and you can't even do the training. It doesn't work at all.
Okay, so let me phrase. Have you guys looked and looked at the market and established what percentage of the deployments that are doing AI training or inferencing are hitting the wall in this manner and therefore buying more GPUs?
I don't have precise numbers,
Okay.
to be honest.
Well, and I
mean,
figured
it's
you wouldn't
growing.
because it'd be hard to do that.
Yeah, I was watching this webcast by a number of venture capitalists, and they were making their predictions. What are going to be the most hot topics in 2025?
Mm-hmm.
And they're going around, and some of the typical ones that you hear. And one of the venture capitalists said, the highlight of what's going to happen in 2025 is the lack of memory capacity for AI processing.
And absolutely agree with that.
Yeah.
Absolutely agree with that.
But I don't have a specific number. I don't know that any research has been particularly published on that yet.
Okay.
But it's a widespread known issue.
Okay.
So we can talk further as we go through the presentation.
Cool.
But no, I want to make this interactive. So I know I've been talking quite a bit. And Camberly, thank you for interjecting with a question, because I want to hear what your perspectives and your experiences are.
So I'll I'll ask the follow-on. Jack Paul, Paradigm
Yeah.
Technica. Kimberly alluded to it, but is this solely a training problem, or is this also current inference?
It's also an issue for inference.
Certainly both.
Yes.
So,
And we'll talk a little bit about that inference performance in just a few minutes.
okay, because that opens up the market significantly.
Oh, yes, it does. In fact, we started on this path initially identifying the fine-tuning problem. Our customers came back to us and said, we have an inference problem too. We ran the models, and particularly for smaller devices that don't have a big memory footprint, by adding more capacity, we dramatically increase the inference performance and experience. And we'll show some charts on that.
All right. Then I'll ask the other follow-ons, which is stupid or not stupid question, is this a problem that could also be solved by redesigning a GPU card? Is it a more memory footprint on the physical board, or is it the GPU can't physically address any more memory?
And I'll have my colleague Sebastian talk about that, but I believe that the constraint about the amount of memory that's on the GPU card, I think, is simply the economics and the physics of the space to be able to fit all that memory alongside that GPU card, and why it's limited. Once again, that earlier chart, the density of memory is not growing as fast as the growth of the size of the models.
Yeah.
So, I mean, memory density is growing, but not as rapidly.
Okay.
And you'd end up having probably pretty massive GPU cards, which then creates all kinds of thermal problems, power problems as well. So, but that's a great question, and maybe Sebastian can talk further about that when he comes join me in a moment. What other questions? Okay, I'll keep going, and feel free to just wave at me, and we'll answer any other questions that come to mind. So this gives perspective on the breadth of not only platforms, but also different price points. So we were showing at the NVIDIA conference an IoT device that was using this very small form factor, looks like a stick of gum, SSD. And so with IoT devices, this can go in, a myriad of different locations, everything from digital signage to your automated vending machines to all kinds of sensors on a manufacturing line. We had a lot of interest from people coming by our booth at GTC wanting to deploy in an IoT edge kind of environment. So
how much storage is on that? Hi, Denise Donoghue.
this can come, it's currently available in 320 gigabytes all the way up to 2 terabytes. And we have on our roadmap to soon be going to 8 terabytes on this. Pretty crazy in regards to the size that you can get with this. And then we have other form factors as well.
Yeah, that's very cool.
So these are the platforms that we've already validated our technology in. And here's a number of the vendors that we have their products on display. We either bought or they loaned us their gear. So you can get this, today, from Newegg, for example, you can get a desktop PC or you can get a high-powered engineering workstation with our technology integrated in. You can order it online right now.
Brian?
Yeah.
Brian Martin, Signal 65. When you say training here, are we talking training base models? Are we talking fine tuning or additional training? What do we mean by training?
That's a great question. So once again, I should make sure everybody's level set. This is really for on-premise use, because you may have a variety of reasons why you don't want to put your models in the cloud.
Lots.
Could be privacy, it could be for cost predictability, a lot of reasons you may not want to have this up in the cloud. So so your question again, sorry, was?
When you say training on
Oh yeah, the training, okay.
Foundation model training
So
or fine tuning an existing foundation?
Yeah, it's fine tuning. So you get the foundational models. You either get the ones that are the commercial ones, the Chat GPTs, the Claude from Anthropic, Perplexity. There's a lot of them that are out there, and then you get the open source versions. Like Meta offers an open source foundational model called Llama. You can download Llama free of charge. You can download DeepSeek, which is also open source, free of charge, but it only has general knowledge. So I'm old enough, I remember the old encyclopedias, right? I'd go to the library, there's this record of the knowledge of humankind sitting there in multiple volumes on a bookshelf, right? However, it knows nothing about me. It knows nothing about my business. Or even in specifics about my industry, it may not even have in there. So that limits the value that large language models can provide to your business. It doesn't give you an edge. But if you can bring those models, download Llama or download DeepSeek, and then augment them, or I'll train them with additional domain-specific information about your business. It could be product plans, customer lists, contracts, all kinds of different things that's unique to you, that's private, you don't want up in the public cloud, but that would help your employees get better answers back, because now we've added to that encyclopedia the knowledge specifically about your firm, your industry. It makes it that much more powerful. So there's a number of techniques that are used to go ahead and augment that information. Retrieval augmented generation, RAG. You'll hear about full model fine-tuning. You'll hear about QLoRa fine-tuning. It's a very dynamic time in the industry as they're looking at the best ways to combine these to get you accurate results based on all the data that's been fed to it.
So just going back to the small storage form factor that you had there, how actually does it work out at the edge? So where would the storage be? So if you've got sensors, where would that plug back into a field server, or what would it?
So I'm going to ask my colleague Loretta, because she's standing right next to a device. If we could grab, there's a device that is very popular out there from NVIDIA called the Jetson family of IoT devices. And there's other versions as well of small form factor computers. So this is an example of a device that's also going to be, it's available from many different manufacturers where they wrap an enclosure around it. And so it can go into these remote locations. It could be on a manufacturing line. It could be some remote sensor in an oil field. This does the processing for that. And so you can see where we've actually installed our memory that's used as a cache to hold the different models to be able to do the AI processing.
And so those would be ruggedized, and they would be within.
Correct.
So would they sit within a larger server, or how would they then connect back to? Then do they go to interim server or router, and then back to the data center?
Yeah, it would be connected over the internet, but also it works where you may not have good internet connectivity, and you could do your processing locally.
Okay.
That's a really key advantage if you're in some far
Rather
remote.
than having to send it all the way back.
Yeah, part of, I don't know, South Dakota, and ain't much internet. This is a way you could do the processing out there locally.
We're going to get letters from South Dakota now. Say, what?
Well, wide open spaces, beautiful country.
Yeah, there you go.
Okay.
Brian,
So-
I do have a question. Matt
Yeah.
Otilaro from Osmium Data Group. There's an interesting thing here in this slide. I mean, there you have servers on the right side, but I see laptops, desktops, workstations, and even IoT devices. And it kind of makes me think, what is your intent in there? If I ask it very bluntly, I mean, is your intent to kind of partner with OEMs, like laptop manufacturers, desktop manufacturers, and so on, to kind of have your technology directly embedded into the devices? Or is it something where you see that customers, I don't know, companies, individuals will go and get that themselves embedded into the product somehow, like buying one of your SSDs or whatever you do?
Mm-hmm. So our initial go-to-market motion is to work with system vendors that they will integrate our technology in there, because it's more than just the SSD. We'll talk more in detail about this, but there's also the middleware that does the memory management, and you could interact with that at a command line, or we also provide an all-in-one tool set in a graphical user interface that goes with it as well. What we do with these manufacturers is that they pre-install this on their equipment, they test it, so when you receive the shipment and you unbox it, it all works. The challenge if you just provide upgrade kits out there, you don't know what the configurations are, and we want to move carefully before we just make it available, in upgrade kits, because they may put it in some custom-built PC that the motherboard is incompatible with the drive, with something, a lot of unknowns. But when we have it shipped out from Newegg in a workstation or a desktop PC, they've already pre-tested it. Maingear, a high-performance laptop manufacturer, will be offering that this quarter. They've already integrated it. It just runs. We're working with a number of IoT vendors that will incorporate the Jetson device in their systems. They've already tested it. We were going to have a server here, actually from MSI, but it's not even arriving until later today. So I couldn't bring it with us, but I would have had that on display as well. So they are all integrating, testing, making sure there's a wonderful customer experience. Maybe down the road we may offer upgrade kits, but that's not the plan right now. So I did also want to give a preview of an expansion of a strategic partnership with yet another platform category. This is in storage systems. So we have a partnership with many different storage vendors, of course, offering our standard SSDs for regular storage. We're now going to be working with SoarOne to offer AI processing as part of their storage system deployment. So this is like an expansion of the partnership, but the actual details of the product, when we will come out with a formal announcement about that specifically later this quarter. So this is, once again, adding to that previous slide, beyond just servers in the data center, now also storage systems in the data center will have AI processing integrated as part of their capabilities.
Can you talk more about what you're doing with them?
We will when we have the detailed
Okay.
product announcement later this quarter.
Okay.
But that's coming. Okay. So I talked about one of the constraints earlier besides the technology, the constraints on being able to scale the memory, the cost of doing so. Another constraint I did mention is just the lack of knowledge. There's not enough people out there who know how to confidently train large language models. So we have worked with Newegg to come up with what we call a teaching PC. Can imagine this available for every student in a classroom, where they have access, all of them, to their own individual systems, and they can do the training right there. You now bring the price point down where it's affordable. Instead of spending millions of dollars, you spend a few $1,000s per student outfitting a classroom, and now they can do the large language model training and the inference research right there as part of their classroom education. So we see that there's been AIPCs out there, but all they did was just do inference. Well, now we go beyond just using an LLM for inference, but now learning how to train in LLM with your own infrastructure. In addition, we realized we needed to take a step forward. In addition to universities, offer our own classes. So we've already been doing this in Taiwan. We've run a number of classes, had a number of students already gone through it. Obviously, there's the course description there on the right in Chinese. We also have a joint venture with a company called MyStorage in Malaysia, and we're offering courses there. We're going to be bringing this also to the US. So it's more than just theory. It's more than just learning what is a AI, what is an LLM, what is inference. It's more than just that. It's actually hands-on workshops where they have the opportunity to do it on their own, access to their own machines that are right there as part of the classroom training. So this is going to help accelerate and alleviate that other bottleneck, which is just lack of knowledge within the industry how to do AI processing.
Quick question. Are you referencing, when we're talking about training LLMs, are you referencing building additional knowledge into foundational models or fine-tuning foundational models?
Fine tuning.
Okay.
So there's a lot of research, a lot of money by very big companies, from Google to Meta to Elon Musk, right? Doing the foundational models. But once again, those are just general knowledge. What we want to do is now make it affordable and accessible by individual companies, state and local governments, universities, that they could do their own research and augment those general knowledge models with unique information that they may want to keep private, but make the LLMs and AI much more useful.